Hi guys, welcome to our tutorial series. Today I have come up with one interesting concept, which is market basket analysis. So machine learning also plays an important role in retail industry where forecasting is done. That means forecasting the performance of sales to identify the buyers. So there are many applications in the retail industry of machine learning, and market basket analysis is one of the best application which analyze the past data and try to find out the frequent patterns or frequent products which are bought by the customers. So what is market basket analysis? So it is dependent on frequent item mining. So then what is frequent item mining? Frequent item mining leads to the discovery of associations and correlations between the items. So whenever the customer visits to the shopping market, so he performs the various transactions, and within the basket he can have the items. So here the analysis is which are the items bought by the customer frequently. So in the database you can have thousands of transactions, then the vast amount of data continuously collected and stored, and the many industries are becoming very interested in mining such kind of patterns from the transactional databases. So one of the best example of frequent item mining is market basket analysis. So this is a process of identifying the customers who are buying frequent items between the different items that the customer place in their shopping basket. So as you can see in the figure, so which are the frequent items bought by the customers? So the probability of the frequent items, like for example, whenever you are purchasing the milk, then whether you are purchasing bread or not. So what are the associated items whenever you visit a supermarket? So you can see the person is thinking, or we can say the market analyst. So he need to analyze the data, and then he need to find out which items are frequently purchased by customers. So you can see the set of customers here, like customer 1, customer 2, 3 up to customer n, and you can also find the items in the basket like milk, bread, right, and cereal. Along with milk, some other items also bought, like milk, bread, butter. Then when the sugar is purchased, then the eggs are also purchased. So these are the transactions, or we can say the customers perform the transactions, and you can find these transactions in the database. So the role of market analyst is to analyze the data and to find out which are the frequent items bought during the visit. Suppose we can think the universe as a set of items available at the store, then each item has a boolean variable which represents the presence or absence of the item. That means the item is present in the basket or not, yes or no kind of analysis. So each basket can then be represented by a boolean vector of values which are assigned to the variables. So boolean vector can be analyzed by buying patterns which can reflect the items frequently associated or bought together. So we need to find the association rule. So that rule contains the items which are purchased. Now the question is, what is association rule? So we can represent a rule in this format. Let I is equals to I1, I2 up to IM. Then what is I? I is an item set which is consisting a set of items I1 to IM, and we can represent data by D, capital D, which is nothing but the database transactions, and this D is having set of transactions. This transaction is a non-empty item set which is having the rule like T is belongs to or subset of I. So each transaction is associated with an identifier, and we are denoting that by TID, transaction ID. Let's consider A. A is the set of items, means which is representing the item set. Then we can also have another set, that is B. So A and B are the item sets, and we can have a rule, association rule, in the form of this: A implies B. That means the items available in B can also be available in A. Available in A can also be available in B, where A no subset of I and B is subset of I, and A intersection B is pi. So the rule, this rule indicates the data set transactions, and this rule is having the support. This rule is having the support. Support is nothing but the percentage of transactions in D which contains A union B. That means items from both A and B. And this rule has to be satisfied with the condition, right? This rule has to be satisfied with the condition. We can set the minimum support threshold value. Similarly, association rule is also having confidence, means which we can denote by C, which is nothing but the percentage of transaction in D containing A and also B. So you need to understand what is the meaning of support and what is the meaning of confidence. So support means percentage of transactions in D which contains A union B, means the items can be available in both item set A and item set B. Whereas confidence means percentage of transactions in D containing A that also contains B. And here we can have a conditional probability like P of B by A or B over A, and this rule has to be maintained support value, that is support of A implies B, which is equals to probability of A union B, and the confidence is represented as probability of B over A, right? So both of these rules should be satisfying the threshold values like minimum support threshold and minimum confidence threshold. In the short form we can say min support and min confidence. And if any rule is satisfying both the minimum support and minimum confidence, and we call that rule as a strong rule. So that rule is called as a strong rule. So basically whenever you do market analysis, so which involves these two steps: first you need to find out all the frequent items, and then step 2 is generate association rule for all these frequent items, right? So first is finding all the frequent items, means each of the items will occur at least as frequently as pre-established minimum support count, and minimum support count we denote with that min sup, means each transaction should be satisfying the minimum support value, and then generating the rule for the frequent item set, and this rule must be also satisfying the minimum confidence. So this is very important basically in database analysis, or we can also say association rule mining. And to do this we need to use algorithms. So in data mining, so these are the two popular algorithms. The first one is a priori algorithm, and this is widely used and well-known association rule algorithm, and it is popular in case of market basket analysis. And it is also considered as one of the accurate over the other algorithms like AIS and also SETM algorithms. And the main objective of this algorithm is it helps in finding the frequent items in the transactions by identifying the association rule between the items. That means the output of this algorithm is association rule, and that association rule is supporting the minimum support and confidence values. And one of the the limitation of this algorithm is frequent item generation. That means it needs to scan the database many times, so this could take time. That means the performance of your system is degraded. So that is the drawback of this, but it is popularly known. So it gives the association rule for the frequent item. Then the second algorithm is FP growth. FE stands for frequent pattern growth. So this is also the another important algorithm, and it represents the data in the form of FP tree, frequent pattern tree. So that means the output of this algorithm is a tree. So from that tree we can find out which items are the frequent. So this algorithm is an advancement to the a priori algorithm. So it gives the graphical view, graphical output. So from that you can get insight from the data. And here one more point to be noted is there is no need for candidate generation, whereas in a priori algorithm you need to generate the candidates, right? But here in FE growth, no need of candidate generations. So it just maintains the structure, right? It just maintains a structure like this. So this is a frequent pattern tree. When you say tree, the tree means there is a root node, and you can be having intermediate nodes, and you can have terminal nodes, right? So here you need to understand what does the node represents. So every node of the tree represents an item set. It represents the item set. For example, this is the node. It is representing the item set 2 with the count, right, with the support count 7, right? This is the support count 7. And then what does the root represents? Root represents the null value. Root represents, this is the root, it represents the null value, whereas the lower nodes represent the items of the data set. So at first no items are generated, that means no frequent items, so that is why null here. But as you move down, you can find the frequent items or representing the node. So the association of these nodes with the lower nodes is between the item set maintained while creating the tree. So the tree is created in this manner. You can see the root node has 2 subnodes, right? I2 is the rule, item 2, the support for that is 7, then count for item 1. This is item 1, count is 2. Means here 7, the support is 7, means the descendant nodes. So 7 means 4 plus 2, 6 plus 1. So the count is 7. Here 2 means here 2. For example, for this node I3 is the item set, and the support for that is 2, means here is a 2, right? This is pointing to I3, like that. So you can see I4. So I4 is, where is I4? This is I4. The support for that is 2. So one is over here and the other one is over here. So 1 plus 1 is 2. So like this it gives the tree. It generates the frequent pattern tree. So that is the benefit of the second algorithm. Now what are the advantages of this market basket analysis? So the advantages, there are many, right? So there are many, and here I have listed the couple of important applications in the retail industry. So the applications are which increase the customer engagement. So we can find out the customer engagement and boosting the sales and increasing the rate of investment, and it also improves the customer experience, optimizing the market strategies and campaigns, and it helps to understand the customer better, identifying the customer behavior and pattern. That means the main the aim of the market basket analysis is which items are frequently purchased. So based on that, the particular company or particular industry can create products, and they can also make an arrangement of products. For example, whenever you go to the supermarket and whenever you are purchasing milk, right, and you might also require butter. So if the milk and butter are placed at different places, then the chances of buying the butter is less. So frequently purchased items are put together so that the customer can find the items and go for purchasing. Now the question is how to implement this. So in order to implement this, so we are taking a data set, stored data, which we got it from Kaggle. I hope you guys have the knowledge of Kaggle. It's one of the leading or #1 platform, open data platform. You can get the data from there. You can do data analysis over the Kaggle platform, and this data set totally has 7,501 transactions. So at first, as you know, we import the required libraries, and if you do not have this, you need to install this library APY ORI. So first you need to install this library. In my case, I'm already having it, so I just go with importing. So here I'm importing pandas, importing numpy, and importing the algorithm, right? A priori algorithm. Then these libraries are imported, and then sorry, I think I missed the library, so let me go with the installation. Which could take a couple of seconds. Yep, it is installed, then importing it, done. And then this is my file market basket analysis, which I kept in my data folder. So data slash the file name, and this file is not having the headers, means column names are not there, so header equals to none. And then data frame is created. Sorry, I think I also have missed the file. So after getting data, you can find this is the data frame, and we do not have the headers. So the by default the column numbers are 0 1 2 3 up to totally we have I think 20 columns are there, 0 to 19. And then we can also check the shape of this. So shape of this is this 7501. The number of rows, the number of columns are 20. And then we can convert this data frame into list of items, right? So this is Python's empty list, and for I in range of 1 to the number of rows. So appending this. So this is list comprehension, right? This is list comprehension, getting the row. So getting the row which are not empty, right, for the column 0 to 20, and then appending that to L. So list is list is created, and after that we can apply the a priori algorithm. So this is predefined one, as you have already imported the library. So association rule, this is user defined variable, which is equals to a priori of giving the L. What is L? List of items. We are specifying the minimum support value here, and also minimum confidence 0.2, minimum lift means support by confidence, so which specify the ratio, and minimum length is 2. Then having the list of association rules, and you can also take help on this algorithm a priori. Then this is the a priori algorithm help. So it is taking the argument, the number of transactions, right? And then so this is the transactions, and these are the parameters like minimum support, minimum confidence. So minimum lift means what is the minimum lift for the relation, the maximum length, right? So this could be the, we are specifying the length as 2. So this is the help available on this particular algorithm, right? So after that we have generated the association rules, and if you want to list out these association rules, we can do that by using a loop for I in range of 0 to the length of association results. So whatever the results generated, we want to display them, we want to print them. So these are the rules, like light cream chicken. So this is one transaction. Mushroom cream sauce and escalope, this is another transactions. Like this, these are all the rules, the combination of items. So these are all the frequent items. So we can also display the rule with their support, right, with their also support and lift ratio by using a loop. For item in the association result means from the above cell we are getting the index, and then displaying the item pairs. Item of 0, right? For item in rule means item in association rule getting the pair, and then index of that, and we are displaying the rule is the argument, right? Items of 1, then support, and then also displaying the confidence, also displaying the lift, right? So this will give us the rule with the measures, like this is a root like light cream and chicken. Combination of these, the support is this much, confidence is this, and lift is this much. Like this we have a rule with their support, confidence, and lift value. So this is the output of the a priori algorithm, and we are also generating the rules, right? We are just having creating a dictionary. So this is Python empty list, rules, support, confidence, lift, and getting item from the association rule, right? Appending the rules, support, confidence, just separating all these and then displaying them as a dictionary. So converting this into a dictionary. So dict1 is equals to rule. So this is a key and this is value, key value, key value. Then creating a data frame. So dictionary is converted into pandas data frame and then displaying the data frame. So this is the data frame, rule, support, confidence, and then what is the lift value. So support, so you see 0.001 like this, the combination of these, right? Pasta and cream, the confidence, support values you can see. We can also sort these in the based on the confidence. So d dot sorting the data frame values based on the confidence. Ascending is equals to false, means descending order, right? So confidence values, these are having, this is having the higher confidence. Cooking oil, spaghetti, and ground beef, the confidence for this is 0.57. So the decreasing order, we are displaying the rules. And we can also apply the second algorithm. So for that you need to install this library. So pip install mlx mlextend. So after installing that, we can import these classes like transaction encoder and from the pre-processing module, and fv growth from the module mlextend dot frequent patterns. So once the library is installed, you can import, and as I've already explained, the output of this fv growth is a tree. So we'll see the tree generated. So transaction is equals to numpy array, converting the list to numpy array, and then creating an object to the class transaction encoder, which will encode the values, and then fitting data to the transaction encoder, then also creating a data frame, right? Creating a data frame and displaying the header part of the data. Now you can see this is the data frame, so whether the item is present or not, true or false. So 5 rows, 120 columns are there. For more information, you can also take help on this fp growth. It will give us the frequent item set from the data frame. So the parameter is df, means data frame, and you can also specify the other values like minimum support, right? And these use column names, maximum length, and verbose equals to 1. So next, giving the data frame as an argument to the algorithm fv growth, specifying the minimum support value 0.0045, use column names false, and then displaying the header part of that. So these are the items, and we are also displaying the support. X has this much support, like this. Individual items we have got it, and then how to have the association rules. So from this module, from mlextend dot frequent patterns, importing the class association rule, and then passing the result, above result, to the association rule, and metric is confidence, and specifying the minimum threshold value, and then displaying the values of this result. So you can see the output here, what are antecedents and what are the consequence, and what is the support for antecedent and support for consequent. Then original support confidence values, also with lift, lev average, conviction, and these metric values. So this is the output of the above code, and then you can sort these rules based on the confidence as we have done in the previous case. So sorting the rules, right? Sorting the rules. So this is antecedent, means above, this is the descendant, and so root, and then children. Then what is the support and confidence for that? So these are displayed, and then we are filtering the data here. So result of lift greater than 2 and confidence is greater than 0.04. So what are the rules? So these are the rules for this filtering, right? We got the rules. For example, rule number 19, for that you can see the lift value is greater than 2 and confidence value is greater than 0.4. so these are the rules. So you can specify the conditions and then you can see the rules with their metrics. And then how to display the result, how to display the FP tree, frequent pattern tree. So for that you need to import this module network X as nx and importing matplotlib, and then we are defining a function here, a draw graph, which is taking two parameters, rules and what is the rule to show. So we are displaying we are having totally 0 to 11 rules, right? 11 rules, and the colors are randomly generated. So colors equals to np dot random dot rand of n, means 50 colors are used, and color mapping, this is a Python list, and creating object to the diagram, this digraph. And then for each rule, so we are appending the word r and then the rule number. So what are incidents and what are the consequence, and displaying them with the graph. So for each rule and then for each node, right? If found a string, if there is a string, then if the string is false, then use found a string as true. If found a string is then yellow color. If there is no string, then green color. So we can see, we can differentiate what is the yellow color and what is the green color. And then we are getting the edges, creating object to the g1 dot edges, right? And then for each color value we are getting the color and weight also. Then this is the important method which can draw the FP tree, and we are showing the graph. So finally we are calling the function, with the number of parameter as 11, result and 11. So you can see what is the rule and then what is the antecedent and what is the descendant. For example, for this rule 2, antecedent is this, right, like this. So the items are with the green color and the rule is represented with the yellow color, and this one gives us the FP pattern tree. And you can also see what is a relation. For example, rule 4, then French fries, eggs, then followed by rule 2, like that. So this one, French fry, above that rule 4 is there, then below that you have eggs, and then mapping with rule 2. So rule 1, rule 2 and rule 4 combination here. This is rule 4 and rule 2, rule 4, rule 2. So this is how it is generated. So you can see the rules with their representation in the tree. So finally this is the FP tree. So that's it from me today. So we have learned how to implement the algorithms, a priori algorithm, and FP growth, and frequent pattern mining is very important, and this market analysis concept is also very important in the retail industries, so that the analyst can find out what are the frequent items, to be purchased. So this is a very interesting one in retail industries. So you can go to the recording, and for any queries you can reach us, you can comment, and do subscribe our channel so that you can get the relevant updates or relevant videos in the future days.